Okay, I'm putting together this recording to help you out with your place value. I want to show you the importance of remembering to use a place value chart, and it'll help everything line up. So first thing I'm going to do is I'm going to draw a place value chart that goes all the way out to billions, because in the problem it says what number is equal to 1,106,260,503. So I'm going to do my place value chart up here. So I need billions, I need 100 millions, I need 10 millions, I need millions, I need 100,000s, I need 10,000s, I need thousands, I need hundreds, I need tens, and I need ones. So I have all of my place values that I'm going to need for this number. Now, remember we have things we call periods, and they're really confusing for some people, but they're separated by these commas when we have a number. And it's every 3 digits from the ones place we have a comma. So this is the ones period, thousands period, millions period, and this is part of the billions period. And the way we teach our students to use this is every one of these commas means we say the name of that period. So when I put this number in here, it'll all start to make sense for them, hopefully. I have 1 billion, so I'll put a 1 there. I have 106 million, so I have 100. I have no 10 millions, and I have 6 millions. Then I have 260,000. 260 and no thousands. And then I have 503. 503. So once I do that, the number's all right there for me, and I can make sure I did it right by just saying it back to myself. 1,106,260,503. And so then all I have to do is compare from here to the answers. When I find one that's exactly the same, I have my match. And I see everything matches along here until I get to this 3. So this is in the wrong place, so A is no good. I check here, I have 1,160,000,000, so that's in the wrong place. I cross that off. This one goes across, 106 there, 260, 503. There is my answer right there. Let's see what's wrong here. Again, we have the 6 in the wrong place. So by using my place value chart and just putting the words in where they go, 1 billion is the comma. That means the one's right in front of the comma. 106 million. The million is the comma. 260,000. The thousand is the comma. 503. Everything works out. Okay. Next problem. Let's zoom in on this one a little bit. It's a little small. Okay. Jason's teacher wrote the following number on the board: 7,082,105. How is this written in expanded form? Again, a place value chart. Every time we work these problems, we should be using our place value chart. This time I only have to go to millions. So I got 100,000. I've got 10,000. Got 1,000. I've got hundreds. I've got tens. And I got ones. And I put my number where it goes. I have 7 million, no 100,000s, 82,105. Once I have it in my place value chart, then everything else as far as doing expanded notation becomes real much easier to accomplish. And what I need is, I need a set of parentheses for every number that has a whole number other than 0 in it. So I need 1, 2, 3, 4, 5 sets of parentheses. You don't have to have one for zeros. Alright, so I'm going to put them down here. 1 set plus 2 sets plus 3 sets plus 4 sets plus 1, 2, 3, 4, 5, and my 5th set. Okay, now inside each one of these, all I have to do is those numbers other than 0, I'm going to put them at the front of each parentheses. 7, 8, 2, 1, and 5. Then all I have to do is I multiply the number by its place value that it's in. This is the millions place, so I multiply by 1 million. The 8 is in the 10,000s place, so I multiply by 10,000. The 2 is in the thousands place, so I multiply by 1,000. The 1 is in the hundreds place, so I multiply by 100. And the 5 is in the ones place, so I multiply by 1. And there it is. So now all I have to do again is compare until I get the right one. A has 10 million. That's not right. So I'll mark A out. B has 7 times a million. That's good. 8 times 10,000. That's good. 2 times 1,000. That's good. 1 times 100. That's good. 5 times 10. That's wrong. So I cross out B. Again, just comparing. 7 times a million. 8 times 10,000. 2 times 1,000. 1 times 100. Oh, and Mr. Hayes wasn't paying attention. These say plus, so none of these are right because of the plus. Boom. Gotta be careful with those signs. So this one must be right. 7 times 1 million plus 8 times 10,000 plus 2 times 1,000 plus 1 times 100 plus 5 times 1. All of those check. So D is my answer. Number 4, if we use the same strategy we did earlier by writing the numbers down in our place value chart, it will make sure we know how to read the number correctly because of the commas. So I need 100 million, I need 10 million, I need a million, I need 100,000, I need 10,000, I need 1,000, I need 100, I need tens, and I need ones. So then all I have to do is plug my digits in where they go. So I have 308 million. I had no 10 millions. I had 76,000, so no 100,000s. 76. Put my comma. I have 238. 238. So if I write it in the place value chart, I can make sure I'm saying my number right. A lot of times our students get confused when these numbers get real big on how to say them. But just remember, you say them in 3-digit groups and then the name of that period. Again, millions, thousands. Wherever there's a comma, that's a word. So how do we read this number correctly? 308 million. Okay, let's see. 380,000. That's wrong. 308 million. That part is correct. 76,000. That is correct. 238. So B is correct. Let's keep going and double check. 308. It doesn't tell me million, so that's wrong. 308,760,000. That's not correct. We don't have 700. So that's wrong. So B is the only possible answer. Doing this table, we're starting with a number, and then we're going to have two different columns that we're going to fill in based off of these numbers. And it's just seeing if they understand place value. Anytime we multiply by 10, we're shifting every digit over one place value. And so the easiest way for me to teach them to do that is just write the same number without any commas. 5, 2, 3, 7, 0, 0. Now when I multiply by 10, I'm shifting all the digits left one place, so I have to add a trailing 0. So I need another 0 when I multiply by 10. Then I go through and put my commas in. 1, 2, 3, comma. 1, 2, 3, comma. And that's all we have to do for that. So same thing here, just write the number without any commas and add a trailing 0. Then go back and put your commas in. Same thing on this one. 960, add your trailing 0, put in any commas. Now when we do 1/10, we do the same thing, except this time we're shifting everything one place value to the right because it's 1/10 of that number. It's getting smaller. Okay, so we just write the number 5, 2, 3, 7, 0, 0. And when I shift everything one place to the right, I'm making this 0 go away. So that means 1, 2, 3, comma. Same thing here. 7, 0, 4, 0, 0, 8, 0. When I shift it to the right, because I'm taking 1/10 of it, that last 0 is going to go away. And this becomes my number 1, 2, 3, comma. Then this one, 960. When I shift all these one digit to the right, this number goes away. So my answer would be 96. Okay. Now, a lot of people say, well, we just move the decimal over. We're not moving the decimal. The decimal never moves. The problem is the place values change. And so we don't want to teach our students that decimals move. And I know that's probably what a lot of you were thinking on this one. Well, we just move the decimal over one. Well, that's not technically correct because the decimal never moves. Okay. All right. It works, but it's not technically correct. We don't want to confuse them. All right. Write this number in expanded form. Again, make a place value chart. Easiest thing to do. So I go all the way up to 10 millions. So I got 10 million. I've got millions. I've got 100,000s. I've got 10,000s. I've got thousands. Got hundreds. I've got tens, and I've got ones. Put the digits in the correct place. Okay. It's easier for a lot of students to get in the habit of putting them in backwards, starting with the ones place. 2, 6, 0, 4, 7, 8, 3, 1. Once they get the idea of what each place value is, this is the 10 million place, this is the millions place, they can feel free to put them in from this direction. Put in their commas at the separation of each period. Okay, now why do we do all that work? Well, now it makes it real easy for us to do expanded form because we just say, what is this number? This number is 1/10 million, or 1 times 10 million, which gives us 10 million. So that's our expanded form. This is 3 million. We write 3 million. This is 800,000. This is 70,000. This is 4,000. We don't have to add the 0 in there. This is 60. And this is 2. So we have completed our expanded form. Now, what I like to remind everybody is take this number and bring it down. And then for every digit back here, add a 0 behind it. So I have a 1, and then 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. I have a 3. And I have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. You get the idea. Okay? And that's how we do expanded form, ensuring that we don't make any silly mistakes. This type of problem is a problem that's used just to see if our students are understanding what value actually means. Okay? So, again, if I make a place value chart, it will really help me. So that's what I'm going to do. I'm going to start out with millions, because that's what my number starts with. And then I need 100,000s. I need 10,000s. I need thousands. I need hundreds. I need tens. And I need ones. And each digit goes in its corresponding place value. So a 2, a 1, a 6, a 8, a 5, a 0, and a 9. So when they ask me which statement about this number is not true, I teach my kids, be sure you highlight that not, because we get so used to not paying attention to directions a lot of times when we're in 4th grade. We really need to pay attention to this word not. It's not that they're trying to trick you, they're just trying to see if you're paying attention. So, the value of the 1 is 100,000. So, is the 1 in the 100,000s place? Yes. So, this is true, but we're looking for not true. So, this is not my answer. The value of the 8 is 80,000. 8 is in the thousands place, so it is not 80,000. So that's not correct, which means this is my answer most likely. The value of the 5 is 500. The value of the 5 is in the hundreds place, so that is, yes, true, which is not what we're looking for. The value of the 6 is 60,000. The 6 is in the 10,000s place, so it is 60,000 value. That's true. It's not what we're looking for. We wanted the false one, so that is B. Again, just make the students do the place value charts. It will help make everything make sense. Okay, now they're just asking about expanded notation in a different form here. So we're going to make a place value chart. We've got 20 million, so I need 10 million, million, 100,000, 10,000, thousand, hundreds, tens, and ones. Now I'm just going to put my digits where they go. This is 2 10 millions, so they go right here. We have 0 millions. My comma goes here. My 100,000s is 600,000. My 10,000s is 7 10,000s, or 70,000. Then 8,000s, 300, 0 tens, and 9 ones. Once I've written it in that form and put my commas in place, okay, it should help me be able to figure out if these values are actually the correct standard form. Now, so what I'm going to do is I'm going to make expanded form off of this number. I'm going to scoot this down and go up above it. No, let's see, I'm going to go down. So you won't be able to see it, but I'm going to make it. So I had two 10 millions. All right, so that's 20 million. Plus, no millions, but I have 600,000. No comma there. I have 7 10,000s, which is 70,000. I have 8,000s. I have 300s. And I have 9 ones. So my answer should look like this and should match. And that's all I have to do is go back and check. Because all I did was put the first digit and then zeros for everything behind that. Okay? And I did that for each digit in my place value chart. Alright, so the first one is 20 million. This is 20 million. This is 200 million. So B's wrong already. This is 20 million and this is 20 million. Then I should have 600,000. This is 6 million. That's wrong. So A's marked off. B's already marked off. C, 600,000. That's correct. D, 600,000. That's correct. Then we go to 70,000. C has 70,000. D has 70,000. Then we go to 8,000. This one has 8,000. This one has 8,000. Then we go to 300. This one has 30. That's wrong, so I mark out C. My answer is D. 300, yes, and 9, yes. So continue to check it all the way through, because if you get to one and you think it's the right one and all of a sudden you see something that doesn't match, well then you've made a mistake somewhere. Go back and double check your work. Alright, so that's how we work that kind of problem. Okay. These statements give our students the most problem. And the reason they give our students the most problem is most of our students do not use the strategies I'm teaching. Okay? We have language barriers with some students. We have some students that just don't understand, even though they speak English at home, they just don't understand the math language. And so if they will utilize my strategies, okay, I'm sure I can get them to where they understand this. We're looking for a true statement. So we have to determine if each one is true. My strategy is to teach them to turn all these words into a number equation. An equation, if it balances out on both sides of the equal side, then it's true. So that's what we're looking for. So I teach them, whatever value you're given, write it above the answer choice. Where you see the word is your equal sign. This is a value, 10. This is a math word, times. That means we're multiplying. As much as just means we're doing it to this number. So I teach them to look and find the equal sign, and whichever side has two things going on, then this is the number on that side of the equal sign that you're doing something to. And that's the problem a lot of times. They want to try to do something to this number, but we're doing it to this number. And if we go back to our place value, our place value always helps us at this age, especially tens, hundreds, thousands, 10,000s. I'll go up to 100,000s. Yeah, that should be enough. Okay, so I'm doing something to the 7,200. 10 times 7,200. So I'm going to put 7,200 first in my place value chart. 7,000s, 200s, no 10s, no 1s. Then I'm going to multiply by 10. They've already told me that they know that when we multiply by 10, we shift everything one place value to the left. So that means when we multiply 10 times 7,200, we should get 72,000. We shift everything one place to the left, add the trailing 0 for the placeholder. So 10 times 7,200 does not equal 720. It equals 72,000. So this is wrong. So we do the same thing with this one. 72 equals 1/10 of 720. So which one do I have two sides, two things going on the same side of the equal sign? It's this one. So I'm doing 1/10 of this. So I start with 720 in my place value term. I'm just going to extend it down so I can keep using it. Create a new problem. So I say 720, 700s, 2 10s, and no 1s. And I'm taking 1/10 of it. When we do 1/10, we're moving everything one place value to the right to make it smaller, which means 720 becomes 72. So B is in effect a true statement. I'm going to keep checking the answers just to make sure I didn't make a mistake. 72,000 equals 10 times 720,000. So if I have 720,000 and I'm going 10 times that number, because these are both on the same side of the equal sign, so I'm doing it to this number, not this one. So this one's going to get bigger. I'm shifting everything to the left by 10. So that would end up being 700, or 7 billion, I'm sorry. What? 7 million. Oh, it's late. Okay, 7,200,000. So obviously it's not 72,000, so this is no good. Again, 7,200 is or equals 1/10 of 720,000. Alright, so extend this down again instead of drawing a whole new one. Alright, I have two things on the side of the equal sign together, so I'm doing the 1/10 to the 720,000. I put 720,000. And I'm taking 1/10, which means I shift everything one place value back to the right. So I'm shifting everything one place value back to the right, so it becomes 72,000. So it's 72,000, but this says 7,200, so this is wrong. So it makes me feel good about my answer B. Everything else I found to be wrong. Alright. And that's all we're going to do for tonight. Thank you.